This podcast is brought to you by Prolongevity, the award-winning 8-week program that can transform the lives of people with prediabetes, type 2 diabetes, and many other lifestyle-related illnesses. Founded by Graham Phillips, the pharmacist who gave up drugs.
Hello and welcome to the latest edition of the Prolongevity podcast. My special guest today is Elliott Overton. Now, as many of you know, I call myself the pharmacist that gave up drugs, and I've become increasingly fascinated by diet and lifestyle and how it affects, how it's the root cause of modern illness. And I often talk about diabetes as a gateway disease to cardiovascular health, neurodegenerative diseases like dementia, and cancer. And I first came across Elliott because I've got a client with Parkinson's disease, and we've been working together for a year. And someone sent me a video around B1 and the B1 protocol and the role of thiamine. And I thought, well, that's really interesting. Let's see if this guy knows what he's talking about. And so I've been sort of following you for a while, Elliott, and it's absolutely apparent that you do know what you're talking about. In fact, your knowledge of cell metabolism is phenomenal. So perhaps you'd like to introduce yourself and just talk a little about your journey and how you ended up here.
Yeah, of course. Thanks for having me on, Graham. It's great to be here. I'm trained as a nutritional therapist. I did some further training in like anti-aging and functional medicine and stuff in the US. I used to practice in the UK. I run a nutritional practice. It's called EO Nutrition, although I don't see clients as much these days. Focus more on research and content creation. I have a YouTube channel. That's how you found me. And I somehow have managed to kind of, let's say, specialize in the concept of using certain vitamins, specifically vitamin B1, in different conditions. That's my area of focus. Is what I'm interested in. And so I now live in France, where I primarily try to focus on raising awareness of how nutrients can improve cell metabolism and how that relates to different chronic diseases that we see today. And yeah, that's an overview.
So we all know about medical training, and it's many, many years of medical training. And I suppose what we know about medical training is it's regulated. Alternative practitioners, I suppose I always say to these people when they first talk to me, I said, there are plenty of snake oil salesmen out there. And you've got to decide for yourself whether I can really help you or whether you think I'm a snake oil salesman. I don't think I am, but that's a decision that you have to make before we start working together. Now, you're not a snake oil salesman. Talk to me a little bit more about your training, because I don't think people realize just how much training, really thorough training, alternative practitioners undertake.
Yeah, okay. So you're right in saying that this industry is populated by, I think, what you could describe as snake oil salesmen. And that's because it's somewhat unregulated. It's not like the traditional medical profession where you have to go through a set specific number of years at an accredited institution, and there are all of these accrediting bodies and things. You go through the traditional university route, and there's not really any other means of doing that. Well, I was 7 or 8 years ago, I guess now. It's gone quick. I faced with that kind of possibility. What do I do? Do I go into medicine? Do I go into nutrition? I was already very interested in the concept of nutrition and familiar with the fact that nutritional guidelines and health guidelines had been thoroughly corrupted, right? Okay. And this concept of, whole grains, and you must eat your five a day, and you must limit your red meat consumption. Well, I knew that was nonsense, because I was testing out an animal-based ketogenic diet at the time before I'd even studied nutrition, and I noticed a lot of benefits from that, and I knew many other people who were doing that. So I was kind of interested in this alternative health movement for a long time before I actually went to study. And so when I decided to take it up as a profession, I was kind of faced with this crossroads. What do I do? Do I go the traditional medicine route? And I looked at my options in the UK, and I decided, well, actually, I'd seen that there are well-known doctors and health professionals and medical professionals who have decided to go against the party line, let's say, and have been threatened with legal action. You know, they've been struck off, they've been threatened by the General Medical Council, and they've been kind of threatened to have their license taken away from them. So I'd been seeing that this was going on, that the conventional system would attack these practitioners. I think it's less common these days, but it definitely was a thing back then. And I decided, well, okay, am I going to go through like 7 or 8 years of medical school with the training only to not recommend drugs, which is like a significant portion of medical education? I'm interested in the natural alternative field. And so actually I want to be looking at how we can improve nutritional status, how we can improve lifestyle factors. We know that these things are generally the most effective for managing and addressing chronic disease. And I was already reading medical journals before I'd even studied. So I come to this conclusion, or I was fairly confident that there was some truth in this. And so I figured, well, why do I want to spend significant portion of my time learning stuff that I will potentially have to unlearn later on? And the same with conventional dietetics. If you look at conventional dietitians, they are forced to recommend NHS guidelines, or based on NICE guidelines. So they're forced to recommend nutritional information to their patients, which frankly does not work. In fact, in many cases, it makes the patient worse. And Absolutely. So I decided, based on a lot of kind of, weighing up the options, that probably my best route, or the best route I could take to have the most professional freedom, was to go an alternative route. And instead of going into medicine, or instead of going into traditional dietetics, I decided to go down the nutritional therapy route. And so I started looking at some of the schools, and I eventually decided on one of the schools called CNM. Now, I'm not saying that this training program did not have its own kind of portion of misinformation, or, its own biases, let's say. But I feel as though the education that I received there was less biased than the conventional route of university education. And so that's the route that I chose to go. It was a 3-year training program. I went on to do several other training programs, another 2-year one, another 1-year one after that. And so ultimately, what I can say is that in my profession, you have a degree of, let's say, professional autonomy. There are accrediting bodies that you have to register up with. There is some degree of top-down control, but there's a lot of personal professional freedom, which is what I was looking for. And what I can also say is that you really get in what you get out what you put in. So there are those people in any kind of profession who will do the minimum to get their qualification. And then that's basically it. Whereas for me, and I think, of course, there are always these types of people who have an underlying thirst for knowledge, who really love their subject. And so for me, instead of reading the bare minimum, I would devour textbooks on biochemistry, on nutritional biochemistry, on physiology. And so ultimately, I would say that there are many alternative health practitioners who although they don't necessarily have the professional accreditation of something like a neurologist or some kind of a medical specialist, they have developed, based off their own back and their own determination, a very competent knowledge base. And that's what I'd like to think that I'm working on. And it's something that we're all working towards. I can tell that this is the case for you. The fact that you've even bothered to change your professional route and be open to all of the other information that you weren't taught in your conventional education speaks to, I think, an underlying thirst for knowledge, or underlying value for truth, what is true. And so I think as long as the value for that is there, then anyone can become competent in their field, and you don't necessarily need to go the conventional route, let's say. So that's kind of why I chose to go the route that I did.
Yeah, and I've kind of gone the other route, which the thing is that pharmacy is a very broad life science degree. So we do learn about cells and mitochondria and transport mechanisms, but we end up in a sort of a dead end. It always leads to symptoms and drugs. And I think if I'm critical of my profession, for which I've been a national representative, it's that we've become the useful idiots for the pharma industry. Mm-hmm. And it's not because we're bad people. It's because we're trained in a particular way, and then we're paid in a particular way. And so one of the things I want to see, I was part of establishing a network called Healthy Living Pharmacy, and it's a nationwide accredited network now, a pharmacist as part of our pharmacy contract. And so I started off with an interest in sexual health and smoking prevention well before the NHS ever did it. And this to me seemed like a natural next segue for healthy living pharmacy, but it's being allowed to wither on the vine. And one of the things I'm pushing for, because there's about to be a complete reimagination of the whole role of community pharmacy, is to take healthy living pharmacy next level with increased accreditation and an emphasis on lifestyle and nutrition and de-prescribing. Mm-hmm. And I'm regularly getting people off medication, which would more than pay for the service. So the funding is there. I think it's completely misplaced. But what I do find is health professionals overwhelmingly are very, very bright people. And once you change your practice and you see completely different results, it's impossible to unsee it. And the results that I see with my eyes on a daily basis, just by making nutritional interventions, primarily lifestyle, sleep, exercise, and the rest of it, blows away anything ever I achieved with the medication. And now I simply can't practice in a conventional way. Right. And one of the things I want to see is an accreditation in the UK for people who practice in the way that we do, to recognise it, so that you can tell the snake oil salesman from the genuine practitioner.
Right. Well, I mean, have you ever heard of ANP, Association of Naturopathic Practitioners?
Not that particular one. No, I haven't.
Okay, so that's the guy who founded CNM. He formed ANP, and it's I don't know if you call it an accrediting body. I guess it is, and that attracts a wide variety of different practitioners. So there's a lot of nutritionists, but also Dr. Sarah Myhill, I believe she's on the advisory board, and you've got some other well-known alternative kind of doctors and things who are involved in it as well. Yeah. So I think that's one of their aims. You might want to look into that to see, because that's what they're looking to do as well, from what I understand.
Yeah. So the other thing that you might find interesting is I'm a trustee of the Public Health Collaboration, and that's a national and international collaboration of people who think like we do. And it's a charity dedicated to improving the nation's metabolic health. So there's tons of free resources on our website. And I think a lot of what you're saying and how you think is how a whole group of us believe. And the other thing for me is that it's a completely non-hierarchical structure. So medicine and professions tend to be very hierarchical, very parent-child, and we're not. So anyway, moving swiftly on. So you look like a young, fit guy. Why on earth would you be interested in nutritional medicine? You should be out there eating all the wrong foods, drinking too much, and partying.
Well, it started for me after going to India. I had developed, I was a long-term vegetarian, actually. Since I was about 4 years old. And so I went backpacking in India when I was 18, and I developed some pretty severe digestive issues. And I went to the conventional doctor. I was basically told that there was nothing I could do about it. And I have a bit of an inquisitive mind. I didn't quite believe them. I figured, well, surely there's a cause for this, and there's actually something that I can do to fix it. And it turned out that they didn't have the answers I was searching for. And so that got me interested in nutrition and the concept of, using medicinal herbs and using nutritional supplements. And I managed to fix it. And I also came to the conclusion very early on that the vegetarian diet that I had been eating for the past 14 years was probably not very good for my health. And some of the things that I was dealing with, emotional issues that I just figured were my personality seemingly dissolved when I got onto a more animal-based approach. And so I found this fascinating, and I started recommending these things to friends and family, and they also began to see benefits. And so this kind of just sparked a passion I never would have anticipated, wanting to know more and wanting to learn more about it. And then it ultimately culminated in me wanting to specialize in it, because it's something that I found so interesting. So there's a lot of value. And there's a great demand in our modern world, a massive demand. I mean, the health of the Western world, at least, is declining at a rapid rate. And it's like, well, no one can answer why that is. They just say that it's genetics or an aging population. I mean, I've never heard so much nonsense. There is very established causes, and it just so happens that none of the conventional medical profession are learning about them. They don't know anything about them. Yet it turns out there's just a massive body of research, whether it's due to underlying nutritional imbalances and nutritional deficiencies, underlying toxicities, looking at the environment these days. You look at plastics, you look at heavy metals, the effect of man-made radiation on human physiology. All of these things kind of culminate in this this mess where human beings are now declining at such a fast rate. And you look at the rates of cancer, metabolic diseases, neurodegenerative diseases, digestive conditions. Anything you look at, it seems seemingly on the rise. And so, living in the UK and looking around at people don't look healthy. They do not look healthy. And that was something that I think I picked on very early on anyway. So there's got to be a reason why this is. This doesn't just happen by chance. So that was a part of it as well. And I suspect it's probably similar for yourself.
Absolutely. So, I mean, I was conventionally trained. And I was, as people heard me say this, when I was a kid, and I'm a lot older than you, I was the only fat kid in a class of slim kids. And now, if you go back to that same class, there'll be one slim kid in a class full of fat kids in a generation, right? Yeah. Well, our genome hasn't changed. We've got the most stable genome probably of any species. So if it's not genetics, what else could it possibly be? It has to be lifestyle.
Yeah, indeed.
Absolutely. One of the things I've realized as a health professional is that none of us are taught any root causes. So we know that we're living in this escalating milieu of increasing what some people call diabetes. So we're getting fatter and more diabetic by the day. And, if you follow the guidelines, the answer to everything is an injection of Wegovy, right? Mm-hmm. So we go straight to what are the symptoms and which drug can we use? The other example I always use is, people are drowning in the river. And you keep wading into the river, and you wade into the depths of the river, and 1 in 3 you manage to sling onto the riverbank and save them. And 2 in 3 drown. Why doesn't someone go to the mouth of the riverbank and work out why people are falling in the first place? That's root cause.
Yeah,
which is kind of what you touched on.
It's insanity. It's the definition of insanity, doing the same thing over and over again and expecting different results. I mean, it's thoroughly bizarre. I never quite understood it, although it would seem as though there's at least a portion of the conventional physicians and dietitians and pharmacists who they just don't seem very curious. It takes a certain amount of curiosity to break out of the box of conventional education and indoctrination, I would say. And it would just seem as though there are the trailblazers who are thinking ahead and thinking outside of the box, and then many who just don't. And that's the unfortunate case for patients. And many patients I personally have worked with would prefer to stay in the box of disease rather than consider alternatives. It's like, even if you had very solid alternatives, some people don't want to hear it. It's like, I never understood that, but it just seems a part of the human condition in that they would prefer to do what their conventional practitioner tells them to do rather than thinking, actually looking at some other evidence and maybe trying something which considered alternative. And that's unfortunate, but it's what we're up against, right?
I think as health professionals, we should be trained how to think, but we're not. We're trained what to think.
Indeed.
And the curiosity that you describe is almost trained out of us. It's bad in pharmacy, but I think it's even worse than in medicine. I had Robert Lustig on, and he's one of the biggest brains in this space. If you haven't read his book, Metabolical, I can't recommend it too highly. It's a fantastic knowledge base for anyone interested in metabolic syndrome and root causes. And he started off doing nutrition. So he was a nutritionist before he went to medical school. And then everything he'd learned was trained out of him.
Interesting.
Until one day a light dawned, like as for some of us. For me, it was my own personal health journey, which was I followed all the guidelines. I knew that red meat was going to give you cancer. I knew that that carbs were lower in calories, and it's all about minimizing calories. So I spent years avoiding saturated fat, avoiding meat, avoiding salt, and eating everything low fat. So it was all high carb. And I spent my life hungry and fat. And the hungrier I got, the fatter I got. The fatter I got, the hungrier I got. I never quite reached the point of diabetes. But one day a light dawned that none of this works. And of course, what you realize is that you've been led up a blind alley by a combination of big food and big pharma and corruption, which kind of runs the system. And once you see the light, because we've got this, all health professionals have got are fundamentally bright and well trained, putting it all together is really quite easy. And once someone switches that light on, you can't go back. So we've kind of talked about this escalating illness, and you've said it's, I agree with you, it's an absolute tragedy. So let's talk about that a bit more. What do you think is causing this? As to say, we're getting fatter, sicker, and more diabetic by the day, while simultaneously spending more and more on the NHS. And I'm a passionate supporter of the NHS. I've worked in it all my life. What's going wrong?
Oh, that's a question. That's a question. What's going wrong? I think there's arguments that could be made on four multiple things that went wrong. First of all, like you said, you have this kind of indoctrination system where the healthcare professionals are, I would say that their common sense is breeded out of them. It's bizarre. It's like if you were to take the average healthy individual, say 60, 70 years ago, and you were looking at what they were eating and you were looking at what they were doing throughout their life, and you see the rates of diabetes, the rates of obesity, the rates of cancer, any health condition across the board was significantly lower back then. Well, you were eating foods that you, first of all, would grow locally and seasonally, one point. Secondly, a lot more animal foods than you would currently eat. So they were minimally processed. So I think that is one of the first things that went wrong, is we discovered ways to process our food on an industrial scale. And that leads to things like nutritional deficiencies, because as you process food, you actually remove the micronutrients. This is kind of my specialization. You remove those micronutrients and you retain the macronutrients, being protein, fat, carbohydrate. And so you end up with this, what Dr. Derek Lonsdale calls high calorie malnutrition, where you consume lots of calories and yet you do not possess the micronutrients to break those calories down break the food down, the macronutrients for energy. Okay, so you end up with this imbalance, and that can lead to a variety of those kinds of diseases. That's kind of my field. But then you look at what they did on the industrial scale with regard to seed oils and fats. Again, this has been discussed ad nauseum. I just want to make a mention of it, is that industrial seed oils, I believe, are one of the driving causes of the diabesity kind of epidemic that we're seeing, and the replacement of traditional fats. But I think you've probably covered this on many other podcasts in the past. There is also the environmental changes. And what I mean by that is the 24-hour daylight that we experience. And this is, I think, massively overlooked. But if you're looking at the way in which the body deals with the food that you consume, well, a lot of that has to do with what's called the circadian rhythm, which I think you may have covered in the past as well. But ultimately, if the 24-hour cycle of night and day being the circadian rhythm is off, which it is in many human beings today, then you can independently induce obesity. You can independently induce diabetes regardless of the diet. And they've shown that in animal studies. And so we do have the exposure to artificial lights. Now, another controversial topic, but if you look at the research, it's pretty undisputable at this point, is the man-made devices that are now so commonplace and have been for the past couple of decades. Whether you look at the man-made artificial electromagnetic frequencies that we are exposed to, this again has been shown to be an independent risk factor for these diseases. And then we have the man-made chemicals, and this is like, there's a very interesting book. It's called Hormone Imbalance Syndrome, I think it was. It was written in the late 90s, I believe. And what they were looking at were the causes of diabetes and obesity. And they were trying to make the argument, I think they did it quite successfully. If you look at many of the statistics in the US, for instance, the soaring rates of hormonal imbalances, of insulin resistance, of obesity, etc., it didn't correlate with changes in diet, or many of the statistics that they collated. It wasn't necessarily correlated with changes in diet per se. It was correlated with the exposure to artificial man-made chemicals. So this being atrazine, this being some of the pesticides, the industrial chemicals that are flooding into the water supply, etc. And they were shown that this could also independently cause hormonal imbalances, problems with how cells are basically using nutrients. So I think that what we're looking at is a multi-pronged issue here. We have EMF, we have diet changes, we have man-made chemicals, we have sedentary lifestyles, we have artificial light exposure. It just goes on and on and on. So I don't think there's, I think there's value to every single one of those arguments. I don't think it's anything one or the other. I think it's a combination of really bad things that humans are now exposed to that have led to the position that we're currently in.
And I put it thus, that we're basically cavemen living in a space age.
Right.
And we only became farmers 10,000 years ago. And, the introduction of the light bulb is, within generations, really. So, and I just think we're maladapted.
Yeah.
And I don't know if you follow the work of Weston Price at all.
Yeah, I had done back in the day.
Yeah, so I had Chris Kenobi on recently from the Ancestral Health Foundation. Chris is training as a medical doctor and then an optometrist. And he got fed up removing people's cataracts. I was trying to understand why people need more and more cataract operations. And he gave up a very lucrative career to do some investigation. And it's fascinating. Weston Price was originally a Canadian dentist who moved to America, and he couldn't find any healthy people. And he wandered around the world looking at traditional tribes who were still leading a relatively normal lifestyle in the mid-20th century. And you could go to an area where American lifestyle had taken over, and the local population would be fat and sick and have terrible teeth. But because up the road, because we didn't have you could be 10 miles up the road and still be leading a traditional lifestyle. So he'd go 10 miles up the road, and the same tribe would be slim, healthy, and have fantastic teeth. Yeah. And he realized it was the Western diseases. I think he called them displacing foods of Western science or something. And he didn't have all the scientific knowledge by them. He was able to describe exactly what you described all that time ago. Yeah. Now, what's also interesting, and something I also learned, Chris, was the first heart attack in the entire world's medical literature was about 100 years ago. So if you look in the medical literature, cardiology and cardiac arrest were basically unknown till around 100 years ago. Right. That was well before there were mobile phones and all of the rest of it. I am increasingly persuaded it all started with the introduction of the processed oils into the diet. Yeah. Because the problem started, if you look at the correlation, and I'm not saying it's the only cause, but I think it was probably the original root cause, was the introduction of seed oils, then the introduction of processed sugars and, eating less and less natural animal foods, feeding the animals on foods that they were never designed to eat. And of course, we're apex predators, so we eat what they eat. And then we've had the growth of the vegan movement, the vegetarian movement, who I think have hijacked the whole thing. So in terms of apportioning blame, because you're not going to change everything, you've got to start by changing, in a logical order. I agree with everything said. Where would you put the majority of the blame? Where would you start if you're going to try and reverse all that to get someone healthy? Because you can't get someone to deal with all those changes in one go. You have to go stepwise. Yeah,
I mean, honestly, I've flipped back and forth with regards to where I place the most value. As a nutritionist, Of course, I'm biased towards the food. That said, there's very, very interesting research looking at keeping animals on the same kind of suboptimal diet, let's say, and just changing the schedule of eating or changing the exposure to light at certain times.
Yeah.
And they notice health improvements with the same diet. What I would say is I think the lowest hanging fruit is changing nutrition because it's the most controllable. There's lots of other things that you can't control. I mean, if you work a night shift, well, okay, long term, it would be good to try and find a different job. But if you have 3 kids and a wife and you need to put food on the table and that's the only way of doing it, well, you can't really change anything about that. Likewise, you might turn your mobile phone onto airplane mode, but every time you go out to the supermarket, you're bombarded by that stuff. Now, the effects are cumulative, but ultimately you can't control that. You can't control a lot of these factors, but you can control your nutrition. And to some extent, you can control your exposure to toxicity. So, my bias is towards the nutrition. It's the lowest hanging fruit, and you can get a lot of those benefits. As it just so happens, I work with a lot of people who nutrition isn't enough for, just the diet isn't just enough. And so they're the more, let's say, complex cases, which require more specific intervention. And that's where we're looking at using things like nutritional supplements and detoxification regimes and things like that. But I think we're probably in agreement that the easiest and perhaps most effective starting point, at least, is going to be changing the diet. Would you agree or not?
Yes, that very much is mine. The two things I start with is that and sleep,
right?
Because almost nobody pays regard to sleep, and there's no drugs for sleep. I mean, none of the drugs. I mean, we know that the medication is very little prescribed now, particularly in this country, the benzodiazepines. And there's been one after another of barbiturates. They were going to solve the problem. Then the benzodiazepines were going to solve the problem. Then the Z drugs were going to solve the problem, and none of them have. So to me, the foundation, I mean, the other example I always give, if you want to kill a human being by depriving them, if you deprive them of water, they'll be dead in a couple of weeks.
Yeah.
If you don't feed them, it'll probably take them 6 months plus, because we've got all this stored fat that we never use. But if you deprive a human being of sleep for 3 weeks, they'll be dead. And I think we do not realize just how important sleep is. So somewhere between those two. But I generally start with nutrition. So let's talk a little bit more then at the level of the organism and the other level of the cell, without getting too far into the weeds, because that's all very well that we think there's this cause, but we've got to be able to give some scientific rigor to this, which is, okay, so if you feed the body the wrong food, I mean, I always say we're fueling our body on the wrong fuels, and or you're on your mobile phone 24/7, and or you never move, and or you're not getting natural light, etc., etc. What happens? What goes wrong?
Okay. In what context? Could you be more specific for me to answer that question concisely?
Yeah, I mean, I suppose I've increasingly become obsessed with the role of the mitochondria.
Yeah.
Because I think basically you disrupt cell metabolism. So when we talk about metabolic health, poor metabolic health, damaged cells, and the damage could be in any part of the body, which would explain what the symptoms are with a single root cause.
Yeah. Okay. Okay. So, interesting theme in a lot of the research these days focuses on exactly what you said in mitochondria, and it's based on this concept that cells make up tissues, which make up organs. And if you go right down to the most fundamental part of your body and how it works, it's a cell, right?
Yeah.
And cells, to do things, they need energy. You think, I mean, you can apply it. It's as above, so below. So, for instance, you as a human being, if you want to clean your house, if you want a clean house, you need to exert energy to take the rubbish out. You need to exert energy to clean. If you want to build something, you have to exert energy, either learning how to build it and then getting the materials and putting them together. If you want to do basically anything that you need to do to survive, you have to work a job, you have to drive around, you have to go places, you have to come back, you have to go to sleep. To do all of that, you have to exert energy to do it. And it's exactly the same at the cell level. Cells require energy in the form of biological energy, ATP. And if they don't have enough energy, then they can't do stuff. It's a really simple concept. And it just so happens that if you look at the majority of chronic health conditions, most conditions actually, there is an element, whether it may be the driving pathology or not isn't quite certain, but there is certainly an element of an impairment in how the cells in that region of the body are generating energy. So for instance, if you look at the heart, one of the primary triggers for the myocardial infarction being a heart attack is an impairment in cell energy. In the brain, you look at neurodegenerative conditions, you look at Alzheimer's, Parkinson's disease, multiple sclerosis, ALS, Huntington's, anything you name it, whether it's occurring at a whole brain level or at a specific region of the brain. For instance, in Parkinson's disease, there is a decline in the production of dopamine from cells in the substantia nigra. So the lack of systemic dopamine leads to their symptoms, okay? If you look at what actually causes the lack of the impairment or the dysfunction in those dopamine producing cells, it is a lack of energy. Likewise, if you look in the liver, what happens in the liver if you have cirrhosis? There's not enough energy to be able to counteract the damage from something else. If cells have energy, they can protect against stress. They can adapt to problems. And this has kind of been well worn out now. So as long as you got enough energy, you can do everything that you need to do. And so ultimately that leads us to this concept that chronic health issues or chronic health problems, no matter wherever it is in the body, generally relates to some extent to an impairment in how those cells are making energy. And we look at how you make energy, and this is really why it's absolutely so bizarre that mainstream medicine doesn't focus on nutrition, is because the way that you make energy is through nutrition. That's why you need to eat. Okay, it's just like breathing air. The reason why you have to breathe is you have to absorb oxygen. Why do you need oxygen? Is to make energy. Okay, but the other half of making energy requires taking nutrients, whether they be the macronutrients or the micronutrients from food, and using them in a way that can generate energy. And so what can happen if we are not giving the right nutrition? Well, one of the first things that can go wrong is that you can't make energy. Hence, the absolute centrality of nutrition for any chronic health condition. It's really simple. I mean, it just boggles the mind why the conventional system just cannot get their head around this. But really, for your listeners, it's that simple. And so my specialization, what I'm interested in, is how those defects in mitochondria or that impairment in energy, how that relates to nutrition, how that relates to specific nutrients, and how you can use potentially nutrition as a whole or specific nutrients to overcome those impairments in energy. Because it turns out that the mitochondria being essentially a powerhouse for your cells, it's how it's it's a powerhouse or an energy factory or whatever you want to call it. Basically, the mitochondria, when they have the right tools, in other words, nutrients, they use nutrients, and when they have the right tools, they can do what they need to do. So it just so happens that most of the research these days, or a lot of it, is focusing on how you can give mitochondria the right tools to be able to achieve what they need to achieve. And when you do that, you see resolution in chronic disease. Okay. And
no, I agree. And it turns out that some cells have a few hundred mitochondria, and the really active cells have a few thousand mitochondria. Now, when I was training, I knew about ATP and AMP and with electron transport training. I knew that was how we generate energy. But this is new stuff, which it turns out, first of all, mitochondria have a very interesting history. Because 4 billion years ago, an archaea, which is a very ancient single-celled organism, swallowed a bacteria. And the two lived happily together ever after. And we don't, not many people know this, but the mitochondria in our cell began life 4 billion years ago as bacteria. And then there was a kind of synergy that developed between the cells. And mitochondria are almost a cell within a cell. They have their own DNA. They have their own separate metabolism. And the mitochondria, yes, they generate power for the cell, but they do so much more. They basically run the cell. They organize the cell. They move around the cell, doing what tasks that need to be done. They can merge and they can split within a cell. They communicate within the cell. And the latest evidence is they can actually move between cells. So it shows you that was how cells went from being single-celled organisms to dual-celled organisms to multicellular organisms. It was the beginning of that evolution, which just shows you how fundamentally important all of that is. So we've talked about energy in a slightly abstract way. And I think this is where the system is wrong, because people think, well, it's just calories, right? Calories is a unit of energy. So long as you're taking in sufficient calories, where's the problem? It's a bit like putting petrol in the car. As long as the tank's not empty and as long as you put petrol in, it's all good. My argument is that we're basically getting a petrol engine and putting diesel in it. So it's not just about calories, is it? So let's say a bit more about, when we've talked briefly about the macros, but I think what gets ignored is the micronutrients. So let's talk about how fundamentally important those things are. In many ways, much more important than raw energy.
Yeah, indeed. So to think of an analogy, I mean, maybe it's a fair analogy, or you could say if you had a petrol engine, you supply it with petrol. But you don't have the engine is actually missing multiple components. So you try to turn the key, and yet the engine won't start, even though it's got enough fuel. And that's kind of equivalent to a mitochondria or a cell that does not possess enough nutrients. So in very basic terms, macronutrients being your carbohydrate, your protein, your fat, they're broken down into much more smaller molecules, simpler molecules. And so carbohydrate broken down into glucose and ultimately into pyruvate, and then it's fed through multiple different steps. And so every health professional or anyone who studies human biology or cell biology will learn the process of what's called oxidative metabolism. And what this basically means is you're breaking down these large molecules which contain energy into much smaller constituent molecules, and then to do that, you have to ultimately act on it via different enzymes, okay? Like multiple different gears, okay, working in conjunction with one another, or cogs in a machine. Whereas there's one step, another step, another step, another step. You don't just take food and convert it into energy. It has to go through numerous steps for you to be able to use and obtain that energy. And to do that, each of those consecutive different steps or enzymes requires what are called cofactors. Cofactors being nutritional molecules, so micronutrients, so being your B vitamins, being your minerals, dietary minerals. You're looking at zinc, you're looking at iron, copper. B vitamins, you're looking at B1, B2, B3, B6, B9, folate, B12. And so basically, to process the energy that's coming from macronutrients, you need to have micronutrients behind that. As it just so happens is that when you have mitochondrial impairment or problems with generating energy, oftentimes it's because of a blockage at one of those steps. So you have enzymes, and those enzymes can be sensitive to lots of different factors. One of those might be mercury, for instance, or arsenic or aluminium. So these toxic metals, one of the mechanisms by which they actually damage cells in the first place is by globbing onto and inactivating these enzymes. And when these enzymes are inactivated, then your cells can no longer make energy. It doesn't matter how much fuel you put in. There's a clog in the engine. It's like you lose the spark plug, for instance. You can't turn the engine on. It doesn't matter how much petrol you have. So you're right in saying that there's this hyper focus on calories, or the amount of energy that can be obtained from your carbs, your protein, your fat. And most diets focus on basically just changing the amount of carbs, protein, and fat. They don't look at, can your cells even use that energy in the first place?
Absolutely.
And that's in the realm of micronutrients. So they barely get any of the attention they deserve. What I would say is that there is the field which you would call orthomolecular medicine. Orthomolecular referring to these small micronutrients. And this is the concept of using micronutrients being your vitamins, your minerals, and other small molecules that you get in the diet in high enough doses or in specific medicinal circumstances to achieve certain effects. And this can be, you can use, there's a lot of work dating back into the 1970s, 80s, using niacin, for instance. And this is probably in your realm, looking at cardiometabolic health. There are just thousands and thousands of people and many doctors, particularly in the US, who've used niacin, otherwise known as vitamin B3, in pharmacological doses. So nothing you would ever obtain from the diet, but something that you could only get via supplemental form. They use it as a drug in certain circumstances to achieve certain effects. So we can use these micronutrients. They do hold medicinal value, but it has to be evaluated on a case-by-case basis based on the individual biochemistry. And this is something that modern medicine doesn't really, they try to place everyone in boxes. They compartmentalize human beings. And they say, oh, if you have this condition, then you take this drug. And that's not the way that human beings work. Because two people can have diabetes, but the cause is fundamentally different in either person. In one person, they might just have a vitamin B6 chromium deficiency, right? That will cause diabetes to some extent. In someone else, they might have something entirely different, which is causing it. It could be just that they eat too much crap. So there are numerous kind of different things that we need to factor in. And this is the concept of like orthomolecularism is, let's say, evaluating someone on a case-by-case basis, looking at their individual biochemistry, spotting the abnormalities in that individual, and then treating them based on that with natural substances. Because ultimately, your body knows how to work. Right? If it gets what it needs to get, then it can work. It's not deficient in drugs, right?
Yeah, absolutely. So we're not all suffering from statin deficiency then?
No, but I mean, you were probably told that we were.
Well, I was told, that I've realized now the way the industry works, which is you find something that's related to a problem, a proxy marker, right? So, one of the people that I follow most is a guy called Matthew Phillips, no relation, and he's a medical doctor who's also studied all this kind of stuff, and he's particularly interested in neurodegenerative disorders, and he says it's germ theory. So back in the day, a single infection treated with a single antibiotic, problem solved. Mm-hmm. And so the theory goes that cholesterol is what causes heart attacks, and amyloid plaques are what causes dementia, and oncogenes are what cause cancer. So we're always looking for a single solution or cause related to a correlation, and we're not addressing the complexity, which, as you said, these things are, cells are incredibly complex. Individual cells, mitochondria are unbelievably complex within cells, and we've got trillions of cells. And not only have we got all the trillions of cells, we've got all the bugs that live within us. It's an incredibly so the idea that a single thing will cause all these problems, that there's a solution which is a statin, you name it, is going to be a solution. And that's where medicines, I think, has gone down a completely blind alley. And what you've described is complex, because it is. Yeah. And until we change that paradigm, we're going to continue to be stuck.
Yeah, you hit the nail on the head. It's highly reductionistic. That's the issue. And it's not only with medical health. It seems to be the case with science across the board. Everything needs to be reduced to, simple cause and effect. And there's not this appreciation, or maybe perhaps there's a fear of complexity, a fear of not being able to understand how something works. It's like you have to be able to put a name to something. You have to be able to, come up with some mechanism by which it causes something. And it's just like, no one knows how the human body works. No one knows how, there's an underlying hubris and arrogance to it, which I think is very common in science, and that extends to study of human biology and health. And I think the best practitioners and the best doctors are the ones who kind of marvel at the complexity and say, look,
Yeah.
I don't know how this works, but I appreciate it. And I have faith that the human body is intelligent enough that if we can push it in the right direction, it can heal itself. And that is really tapping in to, the very, the old traditional forms of medicine, which were not based on reductionistic concepts, but
Yeah.
which were based on an innate intelligence of the human body to fix itself. And that's traditional Chinese medicine, Ayurveda, homeopathy, traditional herbal medicine. All of these different forms of medicine are based on the concept that the human being is driven by some kind of a life force, and we don't know what that is. We can't necessarily measure it, but we know we think it's there, and that is the thing which organizes healing. Yeah. And so our therapies are not going to fix someone. The body fixes itself, but therapies can give it a push in the right direction. I believe that to be true to some extent. The vitalist concept.
Yeah, no, I'm sure that's right. So there are so many different directions we could go to from this point, but I'd kind of like to focus now on where I first came and found you, which was the area of Parkinson's disease and the supplementation. Because I don't think, clearly neither of us are saying, I get companies approach me all the time with their nutritional supplements and saying, sell my product. Right. And I say, I'm the pharmacist that gave up drugs. But you're telling me to sell your product on the basis of carry on with your terrible lifestyle, take my wonder supplement, and you're going to be fine. That's completely charlatan. And I won't do that. So we're very, very, very careful about working with any company that approaches on that basis. Mm-hmm. And when I was trained, I just thought everyone should take a statin and everyone should take a vitamin. And I've very substantially changed my position now. Why? A, because I've realised that the evidence for the benefits of statins is tiny and the evidence for the harms is quite enormous. But I've also realised that our diet, even at its best, tends to be nutritionally lacking because we've leached so many of the fundamentals from the soil that even if you eat well, it's a struggle. And particularly if your metabolism is compromised, that doesn't mean that I don't start first and foremost with lifestyle. I do. But it does mean also that I do believe now that there's a place for supplementation. And this is your area of terrific expertise. So we can't do with all of it, but I think we can pick one area, which is, I've become fascinated by neurodegenerative diseases, and everyone knows about dementia. But actually, the fastest growing neurodegenerative disease is Parkinson's disease. And when you look at what's going on in the mitochondria, they're remarkably similar diseases. There's different parts, different complexes within mitochondria. Yeah, is what we found is the consistent problem. So you sent me a couple of slides, and I think that might be a good place to start. Not because it's the only thing we could discuss, because it's not, but I think it's a useful segue to explaining our philosophy and playing that into one key disease, which I think you could extrapolate that broadly into many others. So I will just pull up a couple of slides and let's sort of have a bit. Let's not get too deep into the weeds, but let's just talk through a couple of things here.
Yeah. Okay. So, like I said, I just by chance happened to kind of specialize in using one of the B vitamins, vitamin B1 thiamine, and I've since come to the conclusion that I believe thiamine has some fairly unique properties in relation to the other B vitamins. I believe it's used by the organism, or many organisms, in fact, as a anti-stress molecule. It possesses anti-stress properties which are kind of conserved among plants, fungi, bacteria, right the way through to human beings. And there's some reasons for that. But ultimately, early on in my nutrition journey, I came across the work of a doctor named Dr. Derek Lonsdale talking about thiamine and why it's so important and how it can be used to treat pretty wide variety of different conditions. I didn't quite believe it at the time because I hadn't heard anyone else talk about it, and I hadn't been taught much about it in nutrition school. But as it just so happens, as I did my research, I figured out that there was a lot in there. And so coming back to that first slide, the work of Dr. Costantini, he was an Italian neurologist, and he basically had studied the use of high doses of this nutrient in patients with neurodegenerative conditions, one of those being Parkinson's. The first started off with a small case study. It was on 3 patients, and it was they noticed anywhere between 31 and 77% improvement. And then you go on to the next slide. It was a slightly larger trial that he did, and it was based on so 33 males, 17 females. They'd also used high-dose thiamine intramuscular injections, and they found between 40 and 50% improvement, and this was after 3 months. They also found that some of the patients had a complete clinical remission. So these are people who were in the early stages. They'd just been diagnosed with Parkinson's disease. They'd had it for a year or 2 years or something. They had a milder phenotype, as in their symptoms were less severe, and they had complete recovery. They went into complete remission. This is practically unheard of in Parkinson's, at least in the medical literature. There is considered to be zero cure, and there is only a condition which cannot halt the progression but can limit some of the symptoms. That's levodopa and similar
which is just a replacement. Yeah, it's a replacement for the missing neurotransmitter in this nigrostriatal pathway, which is a pathway in the brain. Just before we go on, I think there's some interesting background to all of this, which is I was watching one of your videos and it was talking about the Japanese and the introduction of when brown rice was refined to white rice. And I think that to give us some interesting clues. So do you want to just talk a little bit about that?
Yeah, of course. So B1 was the first B vitamin to be discovered, right? It was isolated early in the 20th century, but it'd been known for a very long time that people who consumed, let's say, certain diets, potentially thousands of years ago in China at least, and India, that they would develop a very strange set of symptoms. And this would sometimes respond to eating certain foods, but no one really figured out what it was. It was only in Japan, it was throughout the 1800s, late 1800s, early 1900s. What ended up happening was they began to process their rice. So they had, as you know, they eat a lot of rice in East Asia. And up until they discovered this technology, they were just eating brown rice. And it became let's say, fashionable among the higher classes to start polishing their rice. So you remove the brown portion, you're just left with white rice. Now, this was not only considered more palatable, most people find it is. I personally enjoy white rice more than I do brown rice. Not only was it more palatable, it also became a status symbol. And so the higher classes started consuming massive amounts of this white rice. And over time, the doctors there discovered that these individuals who were consuming this rice would begin to develop a very strange set of symptoms. Sometimes it would affect the heart and cardiovascular system. Sometimes it would affect the brain. Sometimes it would affect the peripheral nerves. So they would develop very strange, lose the ability to properly move their body. They might develop heart failure, pulmonary, edema. Some people would actually die from this. And so they discovered that because these people were eating the white rice, it had to do something to do with that. And so various experiments led to the conclusion that the brown rice was the portion that contained, they called it anti-neuritic factor or anti-beriberi factor. This disease is now known as beriberi.
Beriberi,
So anti-beriberi factor, after some experimentation, it was isolated and they figured out that it was what they called a vitamin, first B vitamin to be discovered, and that's why they called it vitamin B1. So they would give the patients this substance, and all of the symptoms would decline. Now, research since then has discovered that this is perhaps the most important vitamin for how we metabolize carbohydrate. Okay, why is this important in our modern world? Well, what we do is we do a similar thing. There's this concept of high calorie malnutrition. We take foods and we consume highly processed foods, many of them refined carbohydrates and sugars. Now, the intake of sugar needs to be proportional to the intake of thiamine. Otherwise, it can induce a deficiency. Basically, if you think of thiamine as working on some of those different enzymes or cogs in the machine, well, every time you give the machine sugar as fuel, then you use up some of that B1. And as you give the body lots of sugar and carbohydrates, then you can actually deplete it. And so you need to replenish that on a consistent basis. So if you eat whole foods, generally, if it contains carbohydrate, a lot of the times you'll be getting enough B1 in that food as well to metabolize it. But with refined intake of foods, sugars, carbohydrates, etc., then it can very quickly lead to a deficiency in this nutrient. Now, given that it was really important for carbohydrate metabolism, that is particularly relevant in our modern world, can be quite difficult to test for. But I came across that information and I figured, well, actually, that could explain a lot, that could explain a lot. And there's potentially some value to this. Well, it just so happens that the thiamine has been referred to as the gateway to energy metabolism, not only because it's important for how we're metabolizing sugar, but ultimately because the enzymes which use thiamine are particularly important in that they are what are called rate limiting enzymes. So this means that when those enzymes slow down, then other enzyme, the way that the cells make energy slows down as well. So you can't make enough energy if you don't have enough B1. And so
end up with a bottleneck.
There's a bottleneck in metabolism. There's a metabolic block, let's say. And this is quite important because those same thiamine-dependent enzymes in the cell are also particularly responsive or sensitive to other factors which are involved in chronic diseases, particularly neurodegenerative conditions. And so based on this kind of concept or this literature, this neurologist, Dr. Antonio Costantini, decided that he would trial this in his patients with Parkinson's. And so ultimately, based on these results, I know they're only small case studies, he tried to get funding. He tried for years and years and years up until his death. He died during COVID. Until his death, he tried to get funding for more research and they wouldn't do it. Makes you wonder why when you consider the monopoly
no money in it.
Pharma has. Exactly.
No money in it.
It's dirt cheap. But there are now thousands of people who've achieved basically remission or 90% remission from this supposedly incurable condition using just a simple B vitamin. And there are mechanistic reasons for why that might be. But Costantini went on to study it in quite a few other conditions, and he found very interesting results. Now, I would say that he was using a dirt cheap form, and he wasn't using other nutrients with it. And it's important to note that generally when you become deficient or when there's a problem metabolizing one nutrient, generally there might be problems with other nutrients as well. And so this is where our approach differs. But I found it remarkable that just using this one B vitamin could achieve such improvement in this one condition. And so it turns out that this is not only applicable for Parkinson's disease, but other neurodegenerative conditions as well. They've recently found Huntington's disease to respond to it, amyotrophic lateral sclerosis. If you go on to the next slide, I was going to say Alzheimer's, that they found a similar thing in Alzheimer's. Now, the question was, why did it work so well? Well, we know that there is this increased consumption of refined carbohydrates, so people may be deficient, but through lots of laboratory evidence, they've found that in patients who respond to vitamin B1, who have neurodegeneration, they don't think it's because it's addressing a deficiency, okay? So you can measure a lot of these markers of deficiency, and they find that a lot of the people do not have deficiency. What is happening instead is something different. So if you go back to that slide, the quote. So what he said was, at the end of these papers, he says, our aim was not to correct a systemic deficit of thiamine, but rather to increase the activity of enzymes involved in cell production of energy in selective brain regions. So, and what you ultimately find is that if you look at the research on Parkinson's disease, you see that, like we were talking about before, there is a problem with the substantia nigra, this small location of cells in the brain. And if they look at what is happening, like I said earlier, there is this energy deficit. So this mitochondrial dysfunction. In animal research, if you can improve mitochondrial function in that region of the brain, then you can reduce Parkinson's disease. Well, it just so happens, if you look at the mitochondria and you look at what actually goes wrong, what exact portion of this or of the mitochondria, which step is blocked, where is the bottleneck. If you look at where the bottleneck is, you can figure out what to do about it. It just so happens that it is one of these thiamine-dependent enzymes. Turns out that this enzyme is inactivated in this region of the brain. And when they look at these, the degree of inactivation, so if this enzyme is really slow, that correlates quite nicely with the severity of symptoms. In other words, if the enzyme is slightly blocked, the symptoms are mild. If the enzyme is highly blocked, then the symptoms are severe. And so they discovered, based on that, well, maybe this is actually a target. Maybe this is an enzymatic target that if we can give the body something to remove the blockage or to stimulate its activity, maybe that will work. Well, it just so happens that thiamine is one of those things that can do that. By giving high doses of thiamine to the cell, you can increase the activity of this enzyme complex. And given that it's rate limiting, you can therefore improve the overall state of energy metabolism. If you go to the next slide after that, you'll see a similar concept seems to apply in Alzheimer's disease as well. So in Alzheimer's, if you look at the research, there's a lot of evidence that you could describe Alzheimer's disease as a brain-based thiamine deficiency. In other words, if you look at their systemic levels, it's going to be normal. But if you look at the brain or specific regions of the brain, they are deficient in B1, and there's various reasons why that might be. What this indicates is that it doesn't matter what you give in the diet. That really doesn't matter. Even if you improve insulin resistance, you improve a lot of these factors. If there is some kind of a problem with metabolism of B1 in the brain is not going to make energy. So it just so happens that looking at the enzymatic, the activity of this one enzyme that we were talking about before, this thiamine-dependent enzyme, they found something very similar in the brains of Alzheimer's patients. What did they also find? They found that when this enzyme was only slightly blocked, it would lead to slight symptoms. But someone who had severe inactivation of this enzyme correlated very nicely with severity of memory impairment in Alzheimer's disease. So what are they doing now? They're using something called benfotiamine, recently received approximately $42 million in funding for Burke Neurological Institute to study the use of benfotiamine, a thiamine derivative, in Alzheimer's disease, because there's very promising clinical results in the early pilot trials. So ultimately, as it comes to neurodegeneration, it seems as though there is something quite unique about how cells utilize B1. And this seems to apply to ALS. It seems to apply to Huntington's as well. Certainly different forms of dementia, certainly Alzheimer's disease, and certainly Parkinson's disease. And it just so happens that by giving high doses of B1 in these neurological conditions, you can very significantly improve the symptoms in a lot of people. Okay. And that's what I became interested in.
I agree with all that. And if you go back to our starting point, which was what's the root cause? And we kind of agreed it's a diet with the wrong type of energy and not enough micronutrients in. And how does that play into all these diseases? It fits perfectly, and it links. We think of all these neurodegenerative disorders as completely different diseases. That's how we're trained. But actually, if you look at it in this way, they're just the same disease playing out in different parts of the brain. Everything connects with everything. Everything's consistent with everything. And also explains why, and I've only learned this in the last year because I've been studying it. We think about Parkinson's as the overt signs of Parkinson's as a movement disorder.
Mm-hmm.
But if you look at Parkinson's rating scales and you talk to people with Parkinson's disease, that's one of the numerous symptoms that they describe. But when you were talking earlier on of the thiamine deficiencies that the Japanese described as a result of the white rice being substituted for brown rice, all those myriad of symptoms are the myriad and complex of symptoms that people with Parkinson's get. Mm-hmm. And the movement disorder is just the one that we can see. But actually, there's disorders of thinking. We know that there's a relationship between Parkinson's disease and dementia. We know that they have disordered memory. They get depression. And they get all sorts of neurological symptoms way beyond what we conventionally understand. Mm-hmm. And we also know that a lot of those symptoms are quite resistant to the standard drug therapies. So you can improve the movement disorder to an extent by substituting the missing neurotransmitter, but you don't help a lot of the other symptoms. Whereas if you do something that's fundamental to metabolism, all of the symptoms improve.
Yeah.
So everything now starts to fit with everything. And that's why it's so amazing. So if we go from a diet high in energy but low in nutrition, which is what the current Western diet is, and we turn that on its head to an ancestral diet, which is much lower in energy but much higher in nutrition, we solve so many of the problems.
Yeah, it's true. It's true. If you cannot metabolize the energy that you bring in, I mean, this is like almost the definition of diabetes. It's energy overload and the cell's inability to utilize that energy. So it literally rejects glucose. You know, it's like when the cell has too much, without going into the biochemistry, but when you get a higher level of NADH to NAD, for instance, or higher level like of any of these redox, when you see an imbalance between the redox status of the cell will naturally become insulin resistant. It's like that's a protective mechanism. The cell rejects glucose because it physically can't deal with an income of any more energy. And that is one of the reasons why fasting or exercise works so well, because what you're doing is you're using up the energy that is stored in cells, and therefore your cells suck up extra energy in the form of fatty acids and glucose. So ultimately, that's one of the reasons how micronutrient deficiencies can also contribute towards diabetes, because if you're bringing in energy that you can't physically metabolize because you don't have the right tools to do that, then your cells will reject that energy, because ultimately, without going into the details, you let's just say in a simplified way, you don't have a clean burning of fuel. You have a dirty burn, and that dirty burn causes damage to cells. But ultimately, the key point here, the interesting thing about B1, and you might want to look into the evidence on for diabetes and benfotiamine. There's a lot of useful evidence looking at the relationship between thiamine impairment of thiamine metabolism and diabetes. There's a lot of interesting findings there. But the thing that I find most interesting is this concept of using nutrients, in particular thiamine. This is my specialization. Using nutrients to do things that are beyond addressing nutritional deficiency, because there is this kind of dogma, and I would say it also applies to the nutrition, alternative medicine, alternative nutrition field. They do acknowledge the importance of a healthy diet, but there's also this kind of dogma that to benefit from a nutritional supplement, as in a vitamin or a mineral, you must be deficient in that to do that. And what we see from a lot of the evidence on neurodegeneration is that these people are not systemically deficient. So they're eating a diet which is replete, yet they might be deficient in a specific region or organ somewhere in the body, specific region of the brain, for instance, or the pancreas or the heart. And so that's not going to show up on tests, and it's not going to respond to diet. And so if we look at like what actually causes these problems and why people can respond to high doses of certain nutrients, it can be nothing to do with the diet as well. For instance, there's a slide there which I've got looking at what are the things which inactivate alpha ketoglutarate. Sorry, this is just looking at the amyotrophic lateral sclerosis with benfotiamine, and then the previous one was Alzheimer's. But if you go to the next slide, I think it might be so this is looking at one of those cogs in the machine, this thiamine dependent enzyme. The interesting thing about it is that there's lots of things which block its action, which inactivate it, which inhibit it, and those things are not directly coming from the diet. Let's say these things are not a deficiency. So there's lots of things that can produce the equivalent of a deficiency at the cell level without actually being nutrition related. So you've got things which cause oxidative stress. You've got heavy metals. You've got mycotoxins. You've got man-made chemicals and neurotoxins and things like that, which kind of cause these local imbalances or impairments in metabolism, which you can use nutrients to address. And this not only applies to B1, it applies to things like selenium, vitamin C, niacin, vitamin B6. You can have what I want to get across, and the bit that really excites me the most is that the disease process itself, regardless of the cause, can increase the requirement for nutrients which are difficult to obtain from the diet. And that's my main argument for nutritional supplementation. It's that just the process of just living in the modern world increases the demand for nutrients across the board. Like, we are not living in the same environment that we were just 200 years ago, never mind 10,000 or 20,000 years ago. Now, we had stressors, but I think those stressors were things that our body had very highly capable to deal with. Trauma, infection, although they were causes of death, they were natural things which our immune system knows how they can recognize. What we're dealing with now is insidious toxins, chronic infection, for instance, because our immune system is unable to detect it. Lyme disease, Bartonella, Babesia, those kinds of things, chronic viral infections. All of these things thrive when our cells do not have enough energy, and some of the things that can impair the way that cells are making energy are the myriad of kind of like toxic influences that human beings are exposed to these days. And those in and of themselves increase the demand for nutrition far beyond what you can have, what you can achieve through diet alone. And so just based on that simple concept, that's not even saying that the food that we're eating is depleted, because I think that it probably is. But even outside of that context, if you ate a really nutritious diet, chances are, if you have some kind of a disease process or toxicity going on, then you are going to probably benefit at least from some kind of a nutritional supplement, whether that's vitamins or minerals or, whatever it may be. And so there's lots of reasons why, I think a good way to look at it is that we live in man-made, or let's say artificial environments these days. And so sometimes adapting to artificial environments require artificial means and methods.
No, I agree with all of that. So we don't want to just look in vitamin B1 in isolation. So there are two further conversations to be had, really, which is what are the supporting vitamins and minerals? So if you're going to supplement B1, what should the right approach be, particularly in the case of Parkinson's disease?
Okay. So if you've got if you look at the way that cells make energy, like I said, you've got these various cogs, and each one of those steps requires a different combination of vitamins. And so there's this concept which appears to play out in real life, is that if you give the body high doses of one of the nutrients, what it can do is it can stimulate certain processes and increase the demand for other nutrients. So
you kind of move the bottleneck down the road, basically.
Indeed, it can do that. Very potentially. And that can potentially lead to some issues in certain people, and it can mean that some people feel worse when they take isolated high dose vitamins. That's not an argument not to do it, because in some cases it's absolutely essential that they do take that isolated high dose of the vitamin. However, a substantial way that you can avoid or mitigate some of those downstream imbalances is simply by providing a medley of the other nutrients. Generally, when it comes to B vitamins, your body will get rid of what it doesn't need. And that's where it's pretty intelligent, in that you can give massive amounts of B12, for instance, and it will just pee it out. Same thing is applied across the board for the B vitamins, except for maybe vitamin B6, although that's debatable. So when it comes to the Bs, a very safe method is to take a B complex which contains a therapeutic dose, something that is beyond what you would find in food, anywhere from, depends on the B vitamin in terms of the dose, but ultimately any modern B complex with active forms of B vitamins should suffice. So that as someone is giving themselves high doses of vitamin B1, you're stimulating certain processes, and the extra B vitamins can help to match that demand. They don't have to be taken in mega doses. They can just be taken in standard B complex format. Now, there's other things, is that when you're giving an isolated vitamin, you want to look at what else or what other nutrient interactions that vitamin has, for instance. For instance, if you're going to be taking zinc, which is a mineral, you want to keep an eye on your copper levels because they are antagonistic. Same as with thiamine. If you give high doses of thiamine, not only do you want to give a B complex, you also want to consider that magnesium is needed for almost every single step which utilizes thiamine. And so ultimately taking high doses of thiamine can deplete or can increase the demand for magnesium. So the very basic protocol would be thiamine, high dose B complex, and magnesium, generally anywhere between 300 400 milligrams per day. And then sometimes people can benefit from some kind of an electrolyte repletion. This can be sodium, potassium, calcium. Any formula should do, but the most important ones are the magnesium and the B complex behind it. And the reason is because I now kind of have the testimonial of thousands of people who use my protocols for using high dose B1, and what we found is that when you take it in isolated doses, then sometimes it can be ineffective. Sometimes it can lead to symptoms which are really just symptoms of other nutritional deficiencies. So as long as anyone is taking a B complex and magnesium behind it, then generally they're going to mitigate many of those symptoms. And so I have a group online. I have protocols which over 2,500 people use them, including many practitioners use them with their patients. I get a lot of feedback, and we use it for a lot of chronic health issues, whether it be neurological problems, digestive issues, cardiac issues, and then the complex conditions which fall under the umbrella, like fibromyalgia, chronic fatigue syndrome, dysautonomia. All of these kind of conditions in some cases can respond to high doses of thiamine as long as you're taking the medley of the protocol. Different forms are suitable for different people. And what I haven't spoken about is that the Japanese in the 1960s figured out ways to increase the amount that the body absorbs. Because if you use box standard thiamine, you need to use a very high dose, and there's it's debatable about how much you can actually get into the body at any one given time. But there are other forms which have heightened bioavailability and get into the brain. So there's one called benfotiamine, a lot of research behind that. Another one called TTFD, which is my favorite. And then one called sulbutamine. And so these can respond to for different people in different ways. But either way, someone could choose a form. They take a B complex, they take a magnesium, and generally they start with a low dose and they start gradually building their way up. A low dose can be anywhere from 10 to 50 milligrams, and then they can increase to, depending on the form, anywhere between 400, 600 milligrams over the space of a couple of weeks or a month, depending on how their symptoms respond. When someone starts it, they generally get what's called the paradoxical effect. Now, this generally, this means that their symptoms will oftentimes get worse. The more in need they are, let's say the more deficient they are, if they are deficient, usually it means that they will get a more severe reaction when they start the protocol. And that can usually last anywhere from like a week to 2 weeks or 3 weeks. And so they need to start at low dose and go very, very, very slowly and monitor their symptoms. But usually you will see that generally tends to normalize within a short period of time.
One of the things that I don't understand, and I don't know whether you can shed any light. So in this protocol for Parkinson's, you start with a good, decent background of B complex and magnesium. Mm-hmm. Then you cautiously add an escalating dose of thiamine in a variety of forms. And I want to get to the detail of that. As you titrate the dose upwards, you can see actually an increase in the negative Parkinson's symptoms. Now, given that you would expect to see an improvement and you would expect the body to discard the excess, have you any understanding of the mechanism that causes that? Because I know it to be true, but I haven't found an explanation, not one that satisfies me.
Yeah, I would say it's not just Parkinson's. It seems to be every condition that responds to B1 in maybe 60% of people. They will notice it. Something that was discovered in like the early 1900s when they started treating people for thiamine deficiency. They found the same thing. So no one really knows what it is. Dr. Derek Lonsdale suspects, or he theorized, that what might be happening is that when someone is chronically deficient, then a cell, what it will do is it will downregulate enzymes which are not being used, right? So if you need an amount of B1 and you're not getting it, then, maintaining enzyme function as a protein, it can be quite costly. It's like your body's not going to continually make that if it's not even being used. And so what might be happening is a natural down regulation to conserve energy. And then what is happening is that as you give high doses, and one of the reasons why high doses might be necessary is to kind of wake up the cell and send the signal that it can start making new enzyme. This is his theory. I don't know if it's true or not. And part of the adaptation of the cell, so the cell has to adapt to these like pathological circumstances. But then as the cell is readapting to a higher baseline amount of thiamine that it's now got access to, that might be one of the reasons why there's kind of a worsening of changes, let's say. Or I'm not sure. I mean, when it comes to mitochondria, there's a couple of reasons why it could be. I mean, so if mitochondria have adapted in a certain way, and then you start giving massive amounts of B1, what you could be doing is stimulating ATP production, but the burn of energy, let's say, is not a clean burn. You might be getting lots of reactive oxygen species temporarily. You might be having like reverse electron transport. There's various mechanisms by which that might temporarily worsen someone's symptoms. It might be the case that they actually have energy to then make new functional mitochondria. If you've had dysfunctional mitochondria for such a long time, it might be the case that you need to basically clear out what's bad.
Absolutely.
And as you're stimulating dysfunctional mitochondria, you're producing a lot of oxidative stress and you're producing inflammation and things like that. But ultimately, it could be the case that that's a temporary phase that someone needs to go through. They now have a newfound kind of amount of cellular energy that they can start making new via mitophagy and things, actually cleaning out. There's various reasons why that might be. Another theory is that if you're in a chronic state of catabolism, which is the case in a thiamine deficiency, someone is basically breaking down their own tissue to provide what energy they can get hold of. Then what you might see is a temporary kind of rebalancing of the autonomic nervous system. And you may have like a greater tendency towards the parasympathetic response or the parasympathetic. And so you have this kind of imbalance between the nervous system, the two branches of the nervous systems. And as you are starting to supply thiamine, you get like kind of like, how did Lonsdale refer to it? You're saying there's kind of like inefficient outputs from the brainstem and the limbic system. And so, for instance, you can get kind of a tendency towards hyperactivity going towards hypoactivity and then hyperactivity until it balances out. This is based on the early research, which was looking at the reports when they looked at, I'll give you an example, stomach acid. What they found was that in thiamine deficiency, many of the patients displayed either low stomach acidity or high stomach acidity. Okay. If you look at why that is, well, thiamine is important for the vagus nerve and cholinergic tone. The vagus nerve is one of the things that tells the stomach to make stomach acid, right? And so ultimately what you had was in some individuals, they had high, in other individuals, they had low. Now, when they replaced thiamine, what they found was that the people who had low stomach acid temporarily developed high stomach acid, or the patients who had high stomach acid temporarily developed low stomach acid. And then over time, it would balance, or there was multiple different patterns. So someone could have low stomach acid and then get even lower until it normalized, someone high, and then it could get even higher until it normalized. So what that kind of suggested is that thiamine is rebalancing the autonomic nervous system in some way. And in some cases, that can worsen the symptoms that are currently there. It's like if the symptom is because of an autonomic imbalance, then temporarily starting thiamine can kind of temporarily worsen that autonomic balance between it until it rebalances, if that makes any sense. I've written this down somewhere.
No, I think I'm sure the answer's there somewhere, because Chris Palmer in his book on brain energy describes something very similar in terms of brain dysfunction. So if your cells aren't working very well, some become hypo-excitatory and some become hyper-excitatory. So some cells don't respond as you'd expect, and some of them get very triggered. The very triggered one might be epilepsy, or it might be schizophrenia. But in the low case, it might be depression.
Right.
And they're just the opposite sides of the same problem, which is cells either overreacting or underreacting to a given stimulus. And as you rebalance it, things change. And it explains, again, that's why his theory of mental health and metabolic dysfunction, all deriving from mitochondrial dysfunction, it all fits. And it fits with everything that you just said. So I'm sure the answer, that might not be the exact science, but I'm sure the answer is somewhere in among all of that. Okay, so the last thing I really want to discuss is, just like all calories are not the same, just like, lots of other things, all vitamin B isn't the same. And I know you've got some particular views on thiamine, which form, which format, and so on. And you've introduced your own formulations, which we're planning to offer to people. So just talk us a little bit about that.
Yeah, well, as I said before, the issue was when they originally discovered thiamine and they would start treating patients in Japan, the problem was getting enough into some people. You see, the body has mechanisms by which we absorb vitamins, and that's usually via transporters in the gut. Okay.
Yeah.
And these are what are called saturable. So it means that when it passes a certain limit, you can only give a certain amount, and then the transporters are saturated. They can't absorb any more for a certain period of time. Yeah. And because of that, they were finding that they couldn't treat certain individuals who had very severe deficiency. In fact, people who were on death's door, they would lose them. Many of them would die because they just couldn't get enough thiamine in. And so one of the mechanisms, they were playing around with ways in which you could increase bioavailability of thiamine. And they discovered a form called allithiamine, which was found in garlic. Now, as opposed to requiring transporters to get into cells, allithiamine diffused across the cell membrane barrier, basically just melted in. What they found is you could get massive amounts of B1 into cells that were deficient, just using this form allithiamine. Unfortunately, it wasn't very stable. So what they did was they played around with different chemical formulations, and they found a way to come up with a molecule called thiamine tetrahydrofurfuryl disulfide. It has all of the qualities of allithiamine, but it's more stable. They synthesized it. It's more stable. And they do use garlic in the process. So they basically take garlic and then they process it with thiamine, and then it forms this allithiamine molecule. Then they slightly change it, and it means that it's like a stable form which gets into cells. So they manufactured that in the 1960s. Around that same time, they were also studying other derivatives as well. One is called benfotiamine, and that's more common in the West. And another one is called solbutamine. That's more common in the nootropics community. Now, so in the Far East, when they refer to B1 in many of their studies now, they actually they primarily use TTFD. So in Japan, they stuck with TTFD, and they use TTFD in clinical medicine. It's actually a prescription medication over there, but it's a nutritional supplement here. Whereas in the West, they tend to use more benfotiamine and solbutamine. Now, ultimately, all of these different forms possess similar qualities in that they can all bypass the cell membrane, meaning that they don't require a transporter. So if you use bog standard thiamine salts, then you generally have to use very, very, very high amounts to get enough into the cells and to get enough into the brain. Whereas you can use these other forms, and you can use much lower amounts to get a similar amount into the brain and to do other things as well. Yeah. And so ultimately, when it comes to thiamine derivatives, the type of condition that you're going to want to treat the form you're going to want to use depends on the type of condition that you want to treat. So if, for instance, you're trying to treat a peripheral nervous system issue, or even Alzheimer's to some extent, because there's a lot of evidence, you would use something like benfotiamine. On the other hand, if you want to treat dysautonomia, digestive conditions, chronic constipation, chronic digestive problems, then you would probably want to use TTFD. On the other hand, if you just want to increase dopamine output, you might want to use solbutamine. They all have slightly different effects, but they can all provide thiamine at the same time. And this is the point, is that some of the actions of these supplements are not just due to thiamine's role in energy metabolism. There are other effects that they're having on the brain and on the cell and things. So not a lot is known in that regard. When it comes to sources, again, I started using TTFD in clinical practice about five years ago now. And I was based in the UK. You couldn't really get it in the UK back then, and I had to import it from the US. Now, this was very costly, and a lot of my patients or clients weren't interested in doing that because they had to pay the cost.
Yeah.
Secondly, the ones who did get it weren't too happy because some of those individuals are quite sensitive to supplements. Okay, when you work with patients with chronic fatigue syndrome and gut issues and things, they oftentimes they don't tolerate the added ingredients in the supplement, the magnesium stearate and silicon dioxide and things.
What we call the excipients.
The excipients, exactly, the excipients. And there's some people who are actually like fully. I had one lady who gets anaphylaxis from magnesium stearate, so there was no way that she could take that. So most supplements on the market are completely off. They can't take them because they all use these excipients. So I tried to find a way to import this, and I tried to figure out if there was a company who made it without any excipients. It didn't. And so the only option that I had at the time, it was like, well, no one is going to make this, and I can't get these clients who I think really need this form. I can't get them to take this supplement, so I have no option. I'm going to have to actually just make it. So basically, that's what I did. I was like, okay, I'll make a product called Thiamax, and I'll use TTFD because there's only one other company that sells it, and they're based in the US. I'll make TTFD, I'll make it in the UK, and I will make it with no excipients. So that's what I did. And it just kind of grew from there. It was, using this form that is heavily used in Japan that basically no one else makes. There's only one other company, and there's no other company on the market that makes supplements of this kind without fillers. And so that became our company. And, it was originally just for a handful of clients that I was using it with. And then a lot more people got interested in it. And so what we started doing based on my work, I started attracting people from all around the world who were interested in trying high-dose thiamine, and not really anyone else talks about it other than Dr. Derek Lonsdale, and he wasn't practicing. So I was one of the only people who's actually a practicing therapist or health practitioner who is interested in this topic. And so, I started getting people from all around the world, and I started gathering a lot of kind of anecdotal data and clinical case studies and things that I did use. Based on that, I started formulating other products. So one of those is called Thiavite. That is a non-methylated B complex without any fillers. Again, there's not many companies that make non-methylated B complexes. Some people are very sensitive to methyl donors, and so we made that product, and it's got some benfotiamine, it's got some TTFD in it as well. Another product, again, Thiactive B. It's a B complex without any fillers, and which contains benfotiamine and TTFD. And so we have formulated I have formulated this whole kind of. We've got about 5 or 6 products, which are all based on this concept of using high doses of thiamine and supportive nutrients around that. The idea is rather than getting someone to take 15 different supplements, have really bad compliance, well, actually, you can get them to take 3 supplements, and they contain all of the nutrients that are thrown out of kilter when someone does high dose B1. So that was the ethos, but that was the idea behind forming the company and formulating these supplements. It's kind of grown out of that. And our main ethos is that we don't want anything that's non-nutritional. So there's absolutely nothing in our supplements which is not used in some way by the human body as a nutrient. So we don't have any excipients or anything like that, other than the capsule, which is microcrystalline cellulose. That's basically just dissolves in the gut. So that has to do. I mean, I could talk for 6 hours on the different thiamine derivatives. We definitely don't have time for that. I have lots of resources online with regards to, which form does what and blah, blah, blah. And on our website, our company is called Objective Nutrients. But that's basically what we're about. That's how it started.
Brilliant. So we will put all the relevant links in the show notes. What I would say to anyone watching is if you want to see more from Elliott and get a greater understanding of his encyclopedic knowledge of cell metabolism, goes way beyond what we've discussed today, but we only had so much time, and a sense of the things he offered. We'll link to everything in the show notes so people can pick the details up. And obviously, there's things we've bandied around here. There are some complex terminology, and we haven't had the time to explain all of it. But between my various podcasts that I've done, my own website, and Elliott's, anything that you're struggling with, I'm sure you can can pick up on. If people want to contact you, Elliott, and ask some more detailed questions, what's the best way they should go about that?
Yeah, you can contact my PA. Her email is office@eonutrition.co.uk, or just go to my website, my name's Elliott Overton, so eonutrition.co.uk. Yeah, I'm on Facebook, I'm on Twitter, and I'm on YouTube. And that's generally where most people will find me, is on my YouTube channel.
Yeah, and I have to say, your YouTube channel is fantastic. So listen, Elliott, it's been a blast. I've learned lots. I always feel with these conversations that hopefully my patients and clients are learning, but I'm learning as I go. So this is a whole new area for me that really I've only come to in the last 12 months. So I'm very much at the learning stage, and I've learned a great deal from you, and I've learned a lot today. So thank you so much for your time, and I look forward to working together with you in the future.
Yeah, thanks, Graham. It was great to be on, and keep up the great work.
All right, take care.
If you enjoyed the podcast and want to find out more, join our Wellness and Prolongevity Facebook group. Don't forget to subscribe and follow so you never miss an episode, and maybe share to friends and family who might benefit. Finally, if you think you might need help with diabetes, heart disease, or any of the other diseases we discuss, then book a free consultation with Graham. There's absolutely no charge for this, and we would never put you under any pressure. What do you have to lose? Bye for now, and see you for the next episode.